All right, everybody. So what are we going to be doing today? Today what we're going to be doing is other trig functions and reference angles. So in the previous lecture, what we talked about was sine and cosine and reference angles. So really, this lecture is going to be very short. I could have done this lecture with the previous lecture. I just, didn't. So here we go. I don't remember how long the last video was. Maybe it was too long. Anyway, let's go ahead and get started. So just as a reminder of the previous lecture, here's what you should know. Let's see. What is a reference angle? Right? And what it is it's an angle between 0 and 90 degrees, or I should say the angle between 0 and 90 degrees or if you're doing this in radians, it'll be between 0 and pi, or 0 and pi radians, pi over 2 radians, that the terminal side of an angle makes with the x-axis, right? And how you calculate it depends on what quadrant you're in, but I advise not trying to memorize a formula and instead just knowing this definition here. So like if you have an angle, let's say right here, there's an angle, there's your angle theta, then the reference angle would be over here, right? Because you want the angle, like basically the shortest way to get from the angle to the x-axis. So if you're here, this is too far to get to the x-axis, right? That's a longer distance than going straight this way and getting to the x-axis this way. So that's the reference angle, okay? And it's always going to be less than 90 degrees, no matter which quadrant you're in. It could be exactly 90 degrees, but otherwise it's less than 90 degrees. Okay, so what are we going to do with it now? Well, we're going to be using this to calculate trig functions. So I'll remind you of how we do this for the sine and the cosine. So let's just do one example of that. Let's say evaluate. Let's say, no, you know what? I want to change it. There's a bunch of questions like this one in the homework for this section, so I'll ask it this way. I'm going to say, write as, well, I'll say what it is. Write sine of 212 degrees in terms of, or as, the sine of an angle between 0 and 90 degrees. Or they might say sine of an acute angle. They might say it that way. Right? Now, what they want you to do is, first of all, you need to know where that angle is. So remember how to do this. You have 0 degrees there, 90 is straight up, 180 is over here, 270 is here, and so on. Well, 212, you know, must be in here somewhere. We don't have to have it perfect, but it's in that quadrant, right? Because it's in between 180 and 270. So that's your theta is 212 degrees. Now, then what you'd have to do for the reference angle is you would have it right there. There's your theta r, the reference angle. So theta r, you'd have to figure it out based on context here. But hopefully what you can do is you can say, well, if we have 180 degrees, I'm going to move that over here. If you have 180 degrees is this way, right? Oops, that's not the color I want. If 180 degrees is right there, then how far is this much past 180? Well, it should just be 212 minus 180, right? That's how you're going to figure that out. And so you do that, and it looks like 32 degrees. And so that's your reference angle. Now, what that means then is that your sine of 212 is going to be either sine of 32 degrees or negative sine of 32 degrees. Now, I'm not saying that these are both the right answer. I'm saying one of them's right and one of them's wrong. And you have to know which one is which based on what quadrant you're in. And so the way you would figure it out is you would say, we know, let's see, that sine theta is the y value when you're on the unit circle, right? And in this quadrant here, quadrant 3, that is quadrant 3, is the y value positive or negative, right? And the answer is it's negative. So we know that sine theta is y, and in quadrant 3, y is negative. So that means you can go back up here, throw out the positive one, and we would want the negative one. And that's how you would do it. So that's what they mean when they ask you this type of question. Okay, so what do you have to do? You have to have two things that you can do. Number one, find the reference angle, and number two, know whether it should be positive or negative, and that's basically it, right? So you must know two things. Number one, how to find a reference angle. And number two, whether or not the trig function you're looking for is positive or negative. I'm just going to say the sine, plus or minus, of each trig function in each quadrant. And if you know those two things, then you should be able to do this entire section. So we already know how to find reference angles, so what we need to talk about is the sine plus or minus of each trig function in each quadrant. So let's think about this. So let's draw another set of axes. Oh man, I'm gonna delete that because I want it. No, that's not what I wanted. Okay, good enough. Now what I need is a unit circle, so I will draw that. Oh man, how come it does that? Because I didn't draw it to an even number, that's why. I'm gonna delete that and I have to do it again. All right, 1, 2, 3, 4. Well, third time is the charm, right? Okay. Good enough. Okay, you know what? I don't care. I don't even care anymore. So there we go. Now there's an illustrative unit circle here. So we got. I'm not even going to make those straight. I don't even care. Don't even care. Okay. So there's a unit circle. Now, what we've got is 6 trig functions. Now, we know that on the unit circle, you have a point, and that point is x comma y. And then your trig functions are going to be as follows. Sine theta is y. Cosine theta is x. Tangent theta is y over x. Now, we may have not have done this for the unit circle yet, but if this is new information for you, then you're learning it now. So we already knew sine and cosine for sure. Tangent theta, y over x. We have three more. We've got a secant theta, which is 1 over the cosine theta, or 1 over x. We have the cotangent theta. Why, I don't want to do cotangent yet. We have the cosecant theta, which is 1 over sine theta. So that's 1 over y. And then we have the cotangent theta, which is 1 over the tangent theta, and that is x over y. So we've got these 6 different trig functions here, right? So here's our formulas. And, well, based on what quadrant you're in, we should be able to figure out whether they are positive or negative. So let's look at a set of axes again, but with less writing on it. Okay, so we have quadrant 1 here, we have quadrant 2 here, we have quadrant 3 down here, and then we have quadrant 4 here. Now, in the first quadrant here, the x and the y values are both positive, right? And if they're both positive, then that means that every trig function is going to be positive, right? Because if the y is positive and the x is positive, those two are positive, and so is that, and so is that, and so is that, and so is that. They're all positive. So in quadrant 1, all trig functions are positive. All are positive. Okay? Now, in all the other quadrants, it's not going to be that way. So in quadrant 2, we'll use this color. In quadrant 2, the x value is negative, right? Like you have on the x-axis here, you have positive x is this way and negative x is this way. Positive y is this way, negative y is this way. So in quadrant 2, you have negative x values. Well, what does that mean over here? So everything with a y in it is still positive. So we can say that, so sine, and actually I'm going to change what I used to write that. So what's positive? So the y is positive here, so sine theta. The x is negative. The tangent is negative because you'll have y over x, one positive, one negative will give you a negative. And then the cosecant will be positive because that's the other one that has a y in it. Are positive, others negative. Okay. Now in the third quadrant, down here, x and y are negative, right? So x and y are negative. So what's that mean? Well, it means sine's going to be negative because it's negative. Cosine's going to be negative. But when you do y over x, if they're both negative, then the result will be positive. So tangent theta is positive. And what else is positive? Well, not the secant, not the cosecant, because those, again, are both going to involve, one involves an x, one involves a y, but x and y are negative. So not those, but the cotangent will be. So tangent and cotangent positive, others, I should just rewrite that to where it's legible, others negative. And then in our last quadrant here, quadrant 4, x is positive, y is negative. So if x is positive and y is negative, if x is positive, then that's positive, but tangent's negative, secant's positive, cosecant's negative, cotangent's negative. So just cosine and secant. So cosine theta, secant theta, positive. Others, negative. All right, and there we go. That's going to be the case. So that's how you're going to know what sign the trig functions are. And there's even kind of a shortcut, which here's the shortcut. So they put A, S, T, C. So in a calculus class, the way they tell you to remember that is all students take calculus, right? All students take calculus, like that. But this is a trig class, so I believe the way they tell you to remember it is a smart trig class, right? And what it's telling you, by the way, is what is positive in each quadrant. What is positive in each quadrant? And the way it works is A is for all. All of them are positive in quadrant 1. The S, which is smart, but it stands for sine. The T stands for tangent. And the C stands for cosine. Right? Now, if you look at what we have here, that's not everything that's positive, right? They're all positive in quadrant 1. We know that. But in quadrant 2, it's not just the sine that's positive. It's the sine and the cosecant are positive. But the reason that's true is because the cosecant and the sine are very closely related, because the cosecant is just 1 over the sine. Okay, so if they tell you the sine is positive, you're supposed to know that the cosecant is positive as well. So they say sine, but they mean cosecant as well. And same thing in quadrant 3. The tangent's positive, but so is the cotangent, because the cotangent is just 1 over the tangent. And same thing for quadrant 4. The cosine's positive, but so is the secant, because the secant is 1 over the cosine. Okay, so you should know that. Now, another thing is that you should have your unit circle available, which we've talked about. So there's a unit circle on Canvas for you guys, I hope. Let me just log in here. Nope. Actually, I just remembered that Canvas is down. So I'll try one more time, and then I'm going to give up. Log in. No, okay, we're good. We're good. Okay. Where's Math 25? There it is. So handouts and notes, unit circle. There it is, right? This will help you remember the angles, and also I have the formulas right there. And it doesn't say like the ASTC thing, but you know, otherwise it's helpful. What else? In your cheat sheet, which I haven't mentioned, but I suggested that you download it, full of formulas, none of which we understand yet, but it does have these, the right triangle definition and the unit circle definition of the trig functions, which you do need, and you know, lots and lots of stuff that we don't need to know yet. But it has another copy of the unit circle if you want it. All right, so those are handouts that are available to you. Okay, so let us continue on. So that is going to be how to find the sign of a trig function in each quadrant. So let's do some examples. So let's say here's an example. Right? Let's say cosecant of let us say 11 pi over 12 in terms, or as, sorry, actually I'll say as the cosecant of an acute angle. And remember, acute just means between 0 and 90 degrees. Or, because we're in radians, between 0 and pi over 2. In radians. All right, so let's try to do this. So, let's see, we're close to the bottom of the page here, but that's fine. So, there's a unit circle, little tiny circle. Where is 11 pi over 12? Okay, 11 pi over 12, you should recognize 11 pi over 12, right? That's 11 over 12 pi. 11 over 12 is a little bit less than 1. So this is just a little less than 1 pi. Okay, so it's a little bit less than pi. Just doing this to keep it separate here. Pi is where? Well, we got 0. Pi over 2 is 90 degrees. Pi is over here. 3 pi over 2 is down here. And then if you come all the way around, you're back to 2 pi. So where is 11 pi over 12? 11 pi over 12 is here. Not really like that. I wrote that too small, and now it's hard to draw a straight line. It's in there somewhere. So that's your 11 pi over 12. Okay, so you've got this little bit left here, and that's your reference angle. So in order to get that reference angle, theta r is going to be, well, how do you get that little bit? It is going to be pi, which is 180 degrees, minus 11 pi over 12, which is going to be 12 pi over 12 minus 11 pi over 12, which is pi over 12. Okay, once you have that, then what you need is cosecant of pi over 12, and you have to decide between plus or minus. Which one is it? So you have to consult your picture of the quadrants and say, okay, well, we are in quadrant 2. In quadrant 2, sine and cosecant are positive. So shouldn't be plus or minus, it should be basically the plus. You don't need to write the plus. And that would be the answer. Cosecant 11 pi over 12 should be cosecant of pi over 12. Right? So the hard part there is really just finding the reference angle. All right. Another type of problem that you might have in this homework assignment is they can still have you do the problems where they give you either the x-coordinate or the y-coordinate, and then they want you to evaluate a trig function. We've done those before too in the previous section, but let's do one again. So let's say evaluate. What do we want? We just did a cosecant. Let's do a secant. Secant of what? Oh, let's say secant theta. If we know the terminal side of theta crosses the unit circle at, let us say, x comma y, but I'm going to give you the y. I'm going to tell you that the y value is negative 1/5. And theta is in quadrant, I have to tell you the quadrant, otherwise we won't know the answer here. Quadrant, let's say 3. Okay. So, how do we do this? So, the point is, not the point, but something we have to do that didn't turn into a straight line. So the idea is you've got a unit circle, okay? Now, I say the y value is -1/5. So that's like here, right? -1/5 for a y value. But there's going to be two different places where that happens. One over here and one over here. So one on the left and one on the right. But I told you we're in quadrant 3. So we do not want this one because that's not in quadrant 3. Quadrant 3 is over here. Okay? So we need to just find the x and the y coordinates of that point. So you know that the unit circle is x squared plus y squared equals 1. But now I'm telling you what the y value is. It's -1/5. So you substitute that y value in for the y. So you have x squared plus, that's going to be 1/25 equals 1. You subtract the 1/25 over to the other side. You get x squared is 24/25. So x is plus or minus the square root here of 24/25, which is plus or minus, do square root separately on the top and the bottom, and you get this, square root 24/5. Now we can simplify that square root 24 a little bit, so I'm going to do a little bit more work here. I'm going to say x equals, well, first of all, we know that x should be negative, right? Because we're in quadrant 3. So this is like the negative side of x, and this is the positive side of x. So negative square root 24/5. But then you can write the 24 as 4 times 6/5. And then the square root of 4 is 2. So you get -2 square root 6/5. And then that's going to be your x value. Okay. Now what does that tell you? Well, it tells you the coordinates of the point, right? So the x and the y values are, x is -2 square root 6/5, and the y value is what they told us, -1/5. Okay, that's not the answer to the question. What was the question? Right? The question was to evaluate the secant theta. So what's secant theta? So now, secant theta is, according to my formula, the secant theta is 1/x. So secant theta is 1/x, which is 1 over this thing, -2 square root 6/5. Now, whenever you divide by a fraction, you should change it to multiplying by the reciprocal. So when you divide by this, it's the same thing as multiplying by -5/2 square root 6. That denominator should be rationalized, which we've done before, but not often. You should multiply by square root 6 over square root 6 to rationalize. And then you're going to get -5 square root 6 on top, and on bottom you're going to get 2 times 6. So -5 square root 6/12 is what you're going to end up with for that. Now technically, way back here, this is the answer as well, but this is a better answer because we've rationalized the denominator by multiplying by that square root 6/6. So rationalizing the denominator means just no square roots in the denominator. So rationalize denominator. Again, let me write that nicer. Denominator means get rid of square roots in the denominator. And we did. So that's what we were trying to do with that. Okay, so we did it. And that's really the type of problem that you're going to be doing a few of. Another thing you're going to have to do in this homework assignment, if you want, not if you want, you have to. Another thing you're going to have to do is evaluate these on your calculator. So I'm just going to give you a few here. I'm going to say evaluate to 2 decimal places. On a calculator. Okay, hold on. Okay, computer is hard. Where's my notes? Sorry. I lost the notes. They're back. Okay, 2 decimal places on a calculator, and I'm going to give us some things to calculate. So I'm going to go sine, no, not sine. Sine's too easy. Secant, I'm going to go 30 degrees. Then I'm going to go cosecant of, I'm going to go pi over 4. Then I'm going to go cotangent of, let's say, 42 degrees. Let's see, one more. Either secant, cosecant, cotangent. Let's just do a tangent of negative pi over 12. All right, let's evaluate these. Oops. So, how do we do them? We're going to use a calculator, okay? So you can use whatever calculator you want. I've got this one. Remember, the key thing here is making sure you know whether you're in degree mode or radian mode, otherwise you can't get the right answer. So our first one we're evaluating is, where are we? Secant 30 degrees. So we should be in degree mode. All right, so we go over here to our calculator, and you just would go secant 30 degrees. And there's no secant, right? There's a sine, a cosine, and a tangent. No secant. Most scientific and graphing calculators are not going to have a secant, a cotangent, or a cosecant. Okay? They're only going to have sine, cosine, tangent, just like this one does. So the way you have to do this is you have to know that when they ask for secant 30, that is 1 over the cosine of 30. Right? That's why I gave you those formulas up here. Right? That's why I gave them to you in terms of the sine, the cosine, and the tangent. All right, back to here. So you have to type into your calculator 1 divided by cosine 30. That's how you're going to calculate a secant of 30 degrees. Again, make sure you're in degree mode. All right, what is it? It is 1.15 when we round. Okay, so the next one we're going to do is cosecant pi over 4. Well, again, there's no cosecant button, so you need to know that the cosecant is 1 over the sine. So it's 1 over sine pi over 4. Oops. So, back here. So we want 1 over sine pi over 4. So where's my pi key? Let me look for it. Oh, there it is. Pi over 4. There we go. Is that right? Almost. Have to be in radian mode, right? Because pi over 4 is in radians, not degrees. So switch to radian mode to calculate it. All right, what do we get? 1.41. 1.41. All right, same thing here. Cotangent 42 degrees. Cotangent is 1 over tangent 42 degrees. So go back there. Tangent 42. 1 over tangent 42. That's in degrees, so switch back to degree mode. Hit enter. 1.11. All right, last one. Tangent pi over 12. What do we do for that one? Nothing, right? That doesn't need anything special. Tangent pi over 12 or negative pi over 12, we've got buttons for that. So you don't need anything special there. You just type tangent negative pi over 12 and make sure that you are in radian mode, because that's radians. Negative 0.26, but that's going to round up, negative 0.27. Negative 0.27. Okay, so there we go. So you should be able to do these on a calculator. Pay attention to degree mode and radian mode, and you do need these type of formulas. The 1 over, those are actually called the reciprocal identities. You need those formulas if you're going to calculate these on a scientific calculator. Yeah, all right. That should be it for this lecture. So I've got another one coming up, but that will do it for this one. See you in the next video.